Hi everyone, and welcome back to another video. This one is on writing equilibrium constant expressions and their calculations. The question I'm going to work on today is question 11. It's on page 32 of your workbook, so you can reference that if you like. This is a very typical test or exam type question. Okay, so this would be a great one to practice in your studies. All right, so this question, given your equilibrium, methanol is in equilibrium with carbon monoxide and hydrogen. It asks you to calculate the equilibrium constant Kc. Given that at equilibrium there are 0.128 moles of carbon monoxide, 0.155 moles of hydrogen, and 0.0244 moles of methanol, all in a 10-liter flask. All right, so the first thing we're going to have to do in this particular question is to write the Kc expression. A Kc expression is always the concentration of products divided by the concentration of reactants. So I wrote that down first, just so that everybody is aware of what values I'm going to put into my numerator and denominator. So concentration of products, concentration H2, that's squared because of the 2 from the mole ratio, times concentration of carbon monoxide divided by concentration of methanol. So there's my Kc expression. That is the first thing you have to be able to do. The second step is to put your values into that expression and calculate the actual number or the answer for Kc. Now, if you notice in the question, we were not given concentrations. We were given moles of each in a 10-liter flask. All right. This kind of brings us back. How do we calculate concentration given moles and volume? So for every single mole value here, you're going to have to translate that into a concentration before putting it into your Kc expression. That's pretty easy to do, just moles divided by your volume. The volume is 10 in this case, so it's a pretty simple calculation. Now, if you want, you can do all this in one step, or you could calculate each of these concentrations separately and then put that into your Kc. It's really up to you. Whatever you decide is easier for yourself. So 0.155 moles divided by 10 liters. So I'm going to do it all in one step. And then carbon monoxide was 0.128 moles divided by 10 liters divided by my reactant concentration, which is 0.0244 moles divided by 10 liters. Don't forget that hydrogen has to be squared. Very common mistake to leave off the exponents in this particular type of question. So if you're using this in your calculator, if you're going to do this in your calculator in all one step, try to remember to do your calculation twice so that you know you've got the correct answer. It's really common to, make an error in your calculation and then, you get your answer wrong. So you want to try to avoid doing that. All right, so I'm putting all this in my calculator. I'm going to do it all in one step just because I'm pretty confident that I can do this all together, and I got an answer for Kc, 0.00. I'm going to keep my same sig figs here. I'm going to keep 3, 126. And don't forget there's no units for a Kc or a Kp expression, which is great. So one less thing to remember. So there's my value of my equilibrium constant. Now, if we go back to the question, there was a part B and a part C. So part B said, determine whether the reactant or the products are favored under these conditions, and then tell me why. Why are the reactants favored, or why are the products favored? Now, we talked about in class if K was greater than 1, what that meant, or if K was less than 1, what that meant. I'm going to come back to the very beginning here where I wrote Kc is products divided by reactants. So if you think about what you're actually doing to find your Kc value, you're dividing two numbers. And it's either going to be a number, an answer, that's greater than 1 or that's less than 1, depending on your numerator or your denominator, which one is bigger. If my numerator is bigger than the denominator, I'm going to get a value of k that's greater than 1 because I'm physically dividing by a larger, I'm dividing by a smaller number, like 10 divided by 5. I'm going to get 2. If I'm dividing by a bigger number, so my reactant concentration is a bigger number than my product concentration, I'm going to get a K value that's less than 1. So my reactants are more favored in that situation. I got a K value of 0.00126, which is less than 1, which is telling me that this is reactant favored. My denominator was actually a bigger number than the numerator. If the denominator is a bigger number, reactants are in the denominator position. They are more heavily favored. That equilibrium will lie to the reactant side just a little bit more often than it does to the product side. And that's what your K value is telling you, if it's greater or less than 1. All right, let's go to the last part. Part C of that question, what is Kc for the reverse reaction? So K and K reverse are simply reciprocals of one another. So if I know my K value, my K prime is just the inverse, okay? So K prime is 1 over K, or 1 over 0.00126, and I'm going to get for that 793. Oh, let's make sure we can see that there. There we go. All right, pretty straightforward, I think, for part C. If you know K, you can just take the inverse to get the K of the reverse. And that also makes sense when you think about it. If K, forward direction, is reactant favored, because my K was less than 1, then K reverse reaction, reverse side, is going to be product favored. It's going to be a number that's bigger than 1. All right, so that's what we see here with those. Now there's a couple of other examples in the workbook that you can try. You should try definitely how to write your K expressions, and then practice putting in examples of different concentrations for these particular equilibriums. You could make up your own if you like, and just see what you're going to get for K, determine are they reactant or product favored, and then calculate your K reverse. All very good examples to try and practice for your upcoming quiz and your final exam. And of course, if you have any questions, you can always let me know in class, email me. I definitely want to try some of those workbook ones yourself, though. All right, thanks for watching, everybody. I hope you're having a great day. See you later. Bye.